Alright, hello everyone, welcome back. In the previous section, we have been talking about the recurrent neural nets for you. Then in this section, we can move to a new part about how to use recurrent neural net as well as some other models to deal with natural language processing as well as word embedding problems. So in this section, we'll focus more on the natural language processing and word embedding, this specific problem, and we'll consider to use some models, deep learning models especially, to deal with them. Here's our outline for today's talk. In the very beginning, we discussed what is natural language processing problems as well as word embedding problem. We are starting in this section. Then we can move a section on word-to-vector as well as word prediction problems. So for word-to-vector, we have two different methods. The first one is called CBOW, or the continuous bag of words, and the second method is called skipgram. We will discuss the two methods in detail and also illustrate the differences or the similarity with each other, and how can they learn the embedding vectors of the words inputs. After that, we can talk about how to use the recurrent neural nets to do the text generation. We have also mentioned this problem briefly in the previous section when we discussed how to use the recurrent neural nets to do the project stage 4, right? And in this section, we can discuss this problem again, how to do the generation of text with the recurrent neural nets. After that, we can talk about two different varieties of the recurrent neural nets. The first one is called bidirectional RNN, and the second one is called hierarchical RNN. Both of them, they can be applied to deal with text data in different settings. For the bidirectional, we can consider directions or two directions in the input text from both left to right as well as from right to left. As to the hierarchical RNN, it considers the hierarchical structures of documents. Each document we have 0 paragraphs. Each paragraph we have 0 sentences. Each sentence have 0 token inputs. Right? It will be forming a hierarchical structures, and then we can consider further to build a recurrent neural nets in a hierarchical structure to capture such kinds of information in learning and embedding for the words. Okay, so let's talk about natural language processing and word embedding problem first. What is natural language processing? So formally, natural language processing, or NLP by short, it is a theoretically motivated range of computational techniques for analyzing and representing the naturally occurring texts at one or more levels of linguistic analytics. So the main purpose for natural language processing is to achieve human-like language processing for a range of tasks of all applications. So people have been studying natural language processing for a long time, since 1940s. So in the very beginning, we have very simple, also very trivial methods for dealing with natural language processing problems. Initially, this kind of techniques, they are mainly motivated from the this kinds of studies. If we borrow some knowledge from the domain experts of linguistics, then we can further consider to model these kinds of rules in linguistics into our computational models. And following that, people propose to us consider or study some grammar theories as well as conceptual ontologies in the language. And people also consider to study symbolic models in processing the languages as well as some static graphic models following that. If you know some basic information about how people deal with this natural language processing with Markov chain as well as some graphic models, as well as some probabilistic graphic models, then you will have more rich information about how people deal with natural language processing in history. But now, these are the history of natural language processing, in the past years. And in recent years, at the surge of deep learning, people start to consider to use deep learning or the artificial neural networks to deal with natural language processing for modeling. And starting from the 2000s, and neural networks began to be used for language modeling. In 2003, Banjo proposed the first neural language model. In recent years, we have been witnessing so many different also new deep learning models deal with the natural language processing problems. At the bottom, we show the timeline of different kinds of models proposed right now or in the recent years. Since 2003, we have neural language models. Then in 2008, we have multitask learning. In 2013, people started to focus on word embeddings. Then we have some NLP neural nets in 2013, and sequence-to-sequence learning and attention as well as some pre-training models. So these are the development history of natural language processing in the recent years. And we have achieved lots of success. Models apply neural nets to deal with natural language processing problems. So we have mentioned some of them already, like recurrent neural nets, LSTM, and GRU in the previous section. And in this part, we also briefly mentioned some of the models for word embedding, like word-to-vector, and we also discussed some of the variety of models like bidirectional recurrent neural nets and hierarchical recurrent neural nets. In the following section, we also have one special section on transformer and BERT, which are more about this attention as well as pre-trained models. So they are the latest or the state-of-art techniques for handling the natural language processing problems. Okay, so this is the general history for the natural language processing, and in the following page, we also have some basic information about word embedding in natural language processing. What is word embedding? So far, we have been discussing different kinds of deep learning models. By now, I think you should have the feeling what deep learning do actually is to learn the embedding vectors of the input data. This embedding vector will be serving as some like features, right? So we learn some features by learning the input embeddings, by compressing the inputs into some concise embedding vectors. This embedding is very similar to the feature extraction process in conventional machine learning. However, here we are focused on learning this kind of embedding automatically by the model, right? And this embedding will also be adjusted according to the task we are studying, and for different tasks, we can also learn different embeddings for the input data, right? So embedding plays a very important role in deep learning. Similarly, here in natural language processing, word embedding is also the term used for the representation of words for text analysis, typically in the form of real-valued vectors that encodes the meaning of the word, such that the words that are closer in the vector space are also expected to be similar in the meanings, in the physical meanings. So we want to compress the words we have into some vectors. Like in this page, we show you some examples. We have cat, kitten, dog, horses, man, woman, king, queen. These are words, right? They're different words used in the real world. Although there are different words in the real world, however, we know that for some of them, they share very similar physical meanings in the real world, like a cat and a kitten, right? They are both cats. This one is a very small cat, right? They are very similar in the real world meanings compared with other words, right? So also compared with horses, the cat, dog, they are also very close, right? Because they are both representing some pets that we have, right? Compared with other words, these two will be similar, close to each other, right? Also, I mean, men, women, they're also very similar, also close, right? Compared with other creatures on this planet. So the difference between men and women also very similar to the difference between king and queen, right? Because king is normally the man and the queen normally is the woman, right? So if we try to calculate the difference between men and women, the difference should be very similar to the difference between king and queen, something like that, right? In other words, for the words in the real world, even though they are represent different things, however, in terms of the physical meanings, they carry some kinds of information there, right? We need to maintain them in learning representations. In this page, we can embed this kind of words into the embedding vectors, something like this. Each one will be represented as one vector. Inside this vector, we'll have all the real values, right? These are numbers. So normally this kind of embedding vector, the physical meaning is very hard to explain. It's hard to explain what are the physical meanings, what are the entries there in most cases, because we are embedding this kind of words into some concise embedding vectors by deep learning models. It will be something like a black box. I mean, we can get this kind of embeddings. However, its physical meaning will be very hard to explain. Also, according to the learning process, also how to learn this kind of embeddings, we may cast some constraint on learning embedding vectors actually. So for example, in the real world, when we learn embedding for cat and kitten, we make sure they are close to each other, also very similar to each other, right? In other words, we can minimize the difference between the two vectors in the feature space. Also, I mean, because the cat, kitten, and the dog, they are both pets, and we also want to ensure they are grouped together into closer regions in the feature space as well, compared with some other words like house, right? As we mentioned before, I mean, the difference between men and women will be very similar to the difference between king and queen, right? So like in the feature space, if we try to calculate the difference between men and women, I mean, calculate the difference between these two vectors, it will be denoted by this vector, right? The difference. It will be the same or very similar to the difference vector between king and queen, and we want to maintain this kind of constraints, right? So depending on the constraint we have or we cast onto the embedding learning process, then we can learn different embedding vectors for the words. So these embedding vectors can serve as the representation for the words in applications or in the learning models. Also, they can carry the concrete physical meanings as well as some constraints in the syntax about the words as well in language. So this word embedding plays a very important role normally. For many of the models, if we don't pay attention to the embedding process, we can use this embedding as the input or as pre-trained inputs for the words in the following up application tasks. In the next section, when we talk about BERT and transformer, we will mention again what is the meaning for pre-training as well for transfer learning about models as well as the embedding of these words in details. Okay, so this is about natural language processing and word embedding problems we are studying in the natural language processing is area. And in the following part, we have several models to be discussed in detail about how to address these natural language processing and word embedding problems in details.